Hello and welcome to yet another video of Cornerstones of Math. Today we will solve the following problem. A pentagon has side length of 7, 2, 1, x and y in this order as shown above. Problem A says, plot on the xy plane the region that point x, y can exist. So if we have only one unknown variable, say like x only and not y, then the possible values of x or possible range of x, like this inequality, can be expressed as a one-dimensional line like this. But in this problem, we have two variables, x and y. Therefore, whatever values x and y can have must be represented on a two-dimensional plane, like this xy plane, and those values are represented as a region on a two-dimensional plane, a region where point x, y can exist. So the first problem is about finding this region, and problem B says, find the range of x squared plus y squared. Now this is a range of single variable question, because if we let x squared plus y squared as z, then this problem is basically find the range of z. Alright, so now you have understood the problem, so let's solve it right now. First, the possible region for x, y on the xy plane. So the first things first, since x and y are side length of a pentagon, they all must be positive. So we have this as our first and foremost condition. Now let's think about the condition to form a pentagon. Here we will use the famous criteria for possible side length of a polygon. That is, the largest side length must be smaller than the sum of other sides. So in these cases, you can clearly see that 5 is less than 4 plus 3 and 10 is less than 5 plus 5 plus 4. But here in our pentagon case, we have a problem. Among 7, 2, and 1, it is obvious that 7 is the largest. But we do not know what is the largest length among 7, x, and y. Therefore, we need 3 inequalities. First, 7 must be less than the sum of other 4 lengths, so 2 plus 1 plus x plus y. And x must be less than the sum of other 4 lengths, so 7 plus 2 plus 1 plus y. And finally, y must be less than the sum of other 4 lengths, 7 plus 2 plus 1 plus x. So we have obtained 3 inequalities. Therefore, if we rearrange a bit, we obtain, from the first inequality, we have y greater than minus x plus 4. And from the second inequality, we have y greater than x minus 10. And from the third one, we have y less than x plus 10. So combined with this first condition, we have total 4 inequalities. And on the xy plane, their geometrical interpretation is like this. The first inequality means that point x, y can only exist on the first quadrant. The second one means that x, y must exist above the line minus x plus 4. The third inequality means above line x minus 10. And the last one means below the line x plus 10. Therefore, the possible region for x, y, which is the intersection of these 4 inequalities, is this shaded region in the figure. If x and y have values that are inside this region, then they can be the side length of the given pentagon. Also, we have to exclude the boundaries from our region, because none of the inequalities contain the equality sign. Alright, so that was the first problem. Now, the range of x squared plus y squared. Here again, we have to think geometrically. You see, if we let square root of x squared plus y squared as k, then this k is simply the distance between the origin and point x, y. And we have to find the range of k squared, this distance squared. And we can easily find out the lower boundary of that distance. From this obtained region, we can see that the distance from the origin to the point inside the region is greater than this distance to the line y equals minus x plus 4. And I don't even have to bring up the formula, because you can easily find out that since these distances are 4, this distance is 2 times square root of 2. Therefore, x squared plus y squared, which is k squared, is greater than 2 times square root of 2 squared. So we have x squared plus y squared greater than 8. And this is the answer. And that was all for today's video. Thank you for watching, and I will see you in another video.